Welcome, everyone. I was a little nervous about this being so close to the beginning of the year with sort of a blackout over the holidays, but it's good to see you. So, here we go. So, this is a place near Asheville in North Carolina. It's a little town called Marshall, and that's a before picture and an after picture. Hurricane Pauline earlier in 2024. What's one of the interesting things is that that area had been considered climate haven because it was more than 200 miles from the ocean. It was nowhere near Tornado Alley. So they thought, oh yeah, that's great. So this sort of thing can happen pretty much anywhere, I think. I mean, that could be a little town in the Santa Cruz Mountains one of these days. We hope not, but I mean, that's the kind of thing that can happen. Yeah. So this is two recent local things. This is part of the wharf after it washed up against the shore here, after it collapsed. December 23rd. And I like this. I'll read it because the print is probably too small. It says two beds, two baths house, $6,000, brand new waterfront prime apartment. This former part of the Santa Cruz Wharf is now offered as a great oceanside dwelling for rent. No parking unless boats. So it's good to laugh when we can laugh because things are so horrible. This is the Scotts Valley tornado. So who am I? My first career after getting a degree in physics was in silicon chip engineering. And after 20 some years, I became a science teacher and I taught for about 20 years. And after retiring from teaching, I became interested in climate teaching, climate activism. So that's me. Oh, I'm also a docent at a couple of places, Natural Bridges and the Sanctuary Exploration Center. I have grandkids. So I taught a class in spring. Raise your hand if you came to that class, please. Okay, good. So who would like some review of the basic science of climate change? Okay, that's great. I'm totally happy to do that. If I have a room full of experts already, I'm going to go very fast over that. So who knows a lot about climate change already? So the people that know a lot, please feel free to chip in, add things, correct me if I make a mistake. You're part of the resource, so don't feel bored. Okay. Are we about to go backwards? No. So I like this little video.
In 2017, the then president of the second largest greenhouse gas emitting country in the world decided to withdraw his nation from the Paris Climate Accord that had been agreed and signed up to by almost every nation on Earth just 2 years previously. Despite that unilateral declaration, many individual states in the Union made it clear that they continue their own clean green energy transitions and strive to follow the decarbonisation pathways set out at that historic COP21 meeting.
Do that.
One of the first executive decisions he took was to place the USA firmly back into the Paris framework. The Biden administration then went on to develop the Inflation Reduction Act, which, despite being ferociously adulterated by policymakers in Congress, many of whom were in the pockets of special interest lobbyists in the fossil fuel industry, still represented one of the most significant and historic pieces of energy transition legislation anywhere in the world. Now, I don't know whether you keep up with American politics at all, but in case it's passed you by, that guy from 2017 has just been re-elected back into the office of President of the United States. And he says he'll reverse Biden's executive order, take the USA back out of Paris again, and start systematically dismantling Biden's flagship environmental policies. And that's a bit shit, really, isn't it? So how much damage can Donald Trump do to the US energy transition? And how can individual states safeguard the progress they've already made? Hello, welcome to Just Have a Think. So here's a map of the 2024 US presidential election results by county. It's really quite red indeed, isn't it? Not my place to comment on how or why such an emphatic decision came to pass in the land of the free and the home of the brave. I'll leave that soul searching to the good folks in the Democratic Party. Suffice to say, America is a democracy, and sometimes that's what democracies do. My focus for this video is purely on the decarbonisation of the US energy system. So let's start with a few stats that actually make quite encouraging reading. According to the US Energy Information Administration, or IEA, America saw significant growth in clean energy in 2023. Solar power was the fastest growing of any energy source. New capacity additions were up 80% in the first half of the year, and by the beginning of 2024, the country had an estimated 139 gigawatts of solar capacity, which was a 23% increase on the previous year. Wind power capacity was less stellar, but still increased by about 8 gigawatts in 2023, and battery storage installations smashed the previous year, with capacity standing at 16 gigawatts, and that number is expected to have doubled by the end of 2024. Electric vehicle sales increased by 25% in 2023, and investment in the sector more than doubled from the previous year. And greenhouse gas emissions actually went down by 3% during the year, even as the economy grew. Market analysts, Clean Power, found that all in all, the clean power industry added a total of 33.8 gigawatts of new utility-scale clean energy projects, beating the previous record year by 12.5%. They tell us that the US now has some 262 gigawatts of clean capacity on its electricity grid, enough to power the equivalent of 69 million American homes. That equates to 16% of all electricity coming from wind and solar. Developers started construction on another 41 gigawatts of new projects in the last few months of 2023, which brings the total of project capacity in the pipeline to a whopping 170 gigawatts. All told, according to Bloomberg, a total of $206 billion in clean tech manufacturing has been announced during the Biden administration. And let's just have a quick look at where all those dollars went here, shall we? Well, 161 billion of them went into Republican districts, 2/3 of which came as a direct result of the Inflation Reduction Act. In fact, since that legislation came into force, nearly $150 billion of funding has been announced for new facilities producing things like electric vehicles, battery energy storage systems, solar panels, and wind turbines. And almost half of that has gone to the 7 so-called swing states of Arizona, Georgia, Michigan, Nevada, North Carolina, Pennsylvania, and Wisconsin. It's a total of about $63 billion, and it's brought something like 50,000 new manufacturing jobs to those regions. On a national scale, when you add in incentives for the infrastructure projects to actually deploy all those solar panels in solar farms and build out all the wind turbines, nearly $500 billion in total public and private investment has flowed into the economy as a direct result of the historic legislation, creating no fewer than 300,000 new jobs across the country. Clean energy investment and jobs in the sector are growing at twice the rate of the overall US economy. Maybe Kamala and Tim should have mentioned that a bit more during their campaign, eh? 4 of the top 10 leading states for green transition technologies voted Republican in the 2024 election, most obviously Texas, of course, which operates the largest renewable industry in the union, employing roughly 400,000 workers. You're going to jeopardize that, Donald? Good luck with that one, mate. Between 2021 and 2023, the Lone Star State brought in $35 billion in private clean energy investment, bringing total installed wind capacity to a whopping 41 gigawatts and solar capacity to 16 gigawatts. California didn't swing for Donald this time, unsurprisingly, but 40 million people live there, more than 500,000 of whom work in the renewables industry. Renewable generation capacity there reached 33 gigawatts in 2023, representing nearly 40% of total electricity generation. And with the exponentially accelerating growth of battery energy storage, it's quite normal now for renewables to completely displace fossil fuels for many hours during the middle part of each day. I could go on and on, but essentially what I'm trying to say here is that America's got a nice little economic boom going on with green energy, and stamping all over it right now would most likely be as unpopular in states that turn red as it would be in those that went blue. One of the safeguards put into the Inflation Reduction Act was a 10-year, fully protected investment horizon for clean energy projects, many of which, as we've just seen, are in solidly Republican states, providing hundreds of thousands of very well-paid jobs to American workers. Are the representatives and senators of those states going to fight for a repeal that would remove that employment and economic growth from their region? Seems unlikely, doesn't it? And then there's good old Elon, isn't there? I won't elucidate my view on him here because this is a family channel, but I don't envisage the boss of the world's biggest electric vehicle manufacturer doing anything to disadvantage his own businesses as he stomps all over the federal regulatory system, causing damage wherever he goes. So we can at least expect the progress of American-made EVs to be pretty healthy over the course of the next 4 years. According to an assessment by Reuters, published just after the US election result, despite Mr. Trump's pledge to drill, baby, drill, and maximize US oil and gas production, in reality, his policies are unlikely to dramatically slow the US renewable energy boom. In fact, most analysts project that US fossil fuel production will probably look very similar during the Trump administration to the levels seen under Biden, who oversaw a boom in the Permian Basin and New Mexico that's already made America the world's largest oil and gas producer. Growth in that sector won't be determined by policy, it will be determined by market prices. And as global demand for oil and gas continues to dwindle in the coming years, prices will tumble and the profitability of things like fracking will look even more precarious than it does today. Of course, the Trump administration will probably make a real nuisance of itself by hamstringing federal agencies that deliver IRA grants and loans. And Trump himself has already made it clear that he'll immediately halt all new licenses for offshore wind turbines because he thinks they kill birds and send whales doolally. But American offshore wind has barely got going really anyway, and it currently represents a negligible contribution to US clean power, despite the blindingly obvious opportunity it offers. So putting the kibosh on that, although a very stupid and short-sighted thing to do, won't really slow the overall progress of clean energy technologies. So am I suggesting that the accelerating juggernaut of the energy transition is now so unstoppable that it can't be hampered by an ideologically fossil-fueled Trump administration? No, of course I'm not. Don't be daft. I imagine he will do everything he can to completely bollocks up all the good progress that's been made so far, because he's that kind of guy, isn't he? What I am suggesting, though, is that the free market economy, so beloved of the Republican right, will ultimately decide the progress of the transition. And try as he might, Mr. Trump can't wave a magic wand and reverse the precipitous drop in the cost of solar, wind, and battery storage technologies. So whether he likes it or not, his capitalist entrepreneurial buddies will continue to see renewables as a nice little earner for their investors. Just don't mention that climate. And speaking of the climate, here comes the entirely predictable but very important caveat. Despite the record-setting pace of annual installations, the USA is still falling short of what's required for the country to achieve a net zero emissions economy by 2050. And of course, isolationist policies like tariffs could also represent a drag on global progress too. So while the next 4 years might not take us back quite as far as some may fear, it will most definitely not be catapulting us forward either, will it? And as this recent chart demonstrates, it's also worth reminding ourselves that 2024 is on track to be the warmest year on record, taking us above the 1.5 degrees Celsius commitment set out in Paris 9 years ago, and putting us well on track to hit 3 degrees or more of warming by the end of the century. If you're still not sure why that's a very, very bad idea indeed, then make yourself a stiff drink, set aside an hour or so when you can focus all your attention on a large TV screen and watch this chilling documentary from the Potsdam Institute of Climate Research. It may just change the way you look at the world. Anyway, no doubt there are some very strong views on this topic, one way or another. So as always, the place to leave your thoughts is in the comment section below. That's it for this week, though. Thanks, as always, to the amazing folks who support my work.
So what did you think about that?
He's a Brit.
Yes.
Are you gonna give us references and can we have a list of these?
You forgot that. I am going to give you references, and I haven't, and I'll tell you where, but I haven't actually caught that one yet, but I will.
That one you just referenced to?
This one I already have,
Okay.
the video. It's the thing he talked about, the Potsdam Institute. So I'll find that as well.
Okay.
So you can watch this tonight. I'll give you the link if you want to watch it again. So I kind of liked it because it was a common sense. They're not going to mess up their own territory.
Right.
Kind of. So, reason why the states will probably not be going along with all of Trump's crazy ideas. We hope. It's a pretty tricky situation, but Anybody have any more thoughts?
Well, and also I suspect on immigration, the same thing's gonna happen too. Everybody's gonna go, no way we can do without these workers.
That's
you
right.
know,
That's right.
so.
And do you all know that Santa Cruz is a sanctuary county? And that's not from before, it's like reinstated. And there's a group called YAR that's organizing it just in case the immigration people come and they've got a training. I've got some little leaflets back there. So probably locally, things aren't too bad, but just having people so worried and stressed is not good. It's bad, but we'll deal as best we can. Now this is about local stuff. And it features Gary Griggs, who is very popular locally, well known. It's a bit slow to get started. Obviously, we're close to the ocean and sea level rise will affect us.
Welcome to the Sea Level Rise Explorer. It's great to have you here. My name is Gary Griggs, and I'm a coastal geologist and a professor at the University of California, Santa Cruz, and I'm going to guide you through this experience. The burning of coal, oil, and natural gas all produce greenhouse gas that forms a blanket around the Earth. This blanket traps heat, causing global temperatures to rise, which can intensify severe weather patterns, but also cause glaciers and ice sheets to melt, seawater to expand, which both raise sea levels. These changes will create major disruptions for our planet and impact coastal communities in many ways. The city of Santa Cruz is an active and vibrant coastal community where residents and tourists use the beaches and bluffs for a variety of recreational activities. Santa Cruz will experience rising sea levels and possibly increased coastal storms, causing more frequent and intense coastal flooding and beach and bluff erosion. Future sea level rise will gradually impact private property, public infrastructure and safety, as well as jobs, surfing, and coastal access in Santa Cruz. Here's the Santa Cruz Wharf, visited by nearly 2 million people each year. We're going to take a look at 3 key Santa Cruz destinations. Dells Beach is one of the most popular in Santa Cruz. On your left is the Dream Inn, and on your right is the base of the wharf. Select the circle on the left side of the scale in front of you and drag it slowly to your right.
So I'll be giving you the link so you can play with this for yourselves. For now, I'll just show you what
See
it
that
does.
water filling in? The king tides, the highest tides of the year in the winter of 2019, brought the water line almost to the street. When you drag the circle all the way to the right, you will see a projection of the combination of 2.4 feet of sea level rise with an extreme storm. While we're uncertain when sea level rise will reach 2.4 feet, it is expected to come well before the end of the century.
I work at this place.
Let's head over to Mitchell's Cove now. See the target flashing on your left. Click there. Mitchell's Cove is
live
about a
close to
mile
here.
up the coast from Cowles Beach and situated below 30-foot high bluffs and adjacent to the scenic West Cliff Drive. These bluffs have experienced erosion over time, and the city has placed boulders or riprap along their base for protection from storm surges and wave action. As you pull the circle across the scale, you can watch projected sea level rise up against the cliffs. With sea level rise, this beautiful section of coastline will erode, altering the coastline, the pedestrian path and roadway, and eventually the neighborhood.
So it's actually already not
Projected
quite like
coastal
this
erosion.
because there was very bad damage in January 23. So sections along here, there are several sections that they've been working on. And a couple of them are almost finished. One of them's not quite finished. So some of this already happened. So this is king tide. Beach disappears. And then
By the year 2100, one scenario indicates coastal erosion on the conservative side could be where the pink line falls. The yellow line indicates a more extreme erosion scenario.
the city
So what
does
might the
have a
city
plan.
do? Click on coastal adaptation and look closely to see the rock armoring. To slow erosion along this part of West Cliff, the city can consider multiple solutions. In this option, the city would repair the existing rock armoring in the short term and could potentially construct a seawall that mimics coastal features as a medium-term solution. The seawall would slow erosion and maintain the recreational pathway for pedestrians and cyclists. But since the beach will not be able to move back due to the seawall, as sea level gradually rises, eventually the beach or portions of it will be lost, reducing the space for public use. To what extent do you agree with the following statement related to coastal management for Mitchell's Cove? Adding a seawall as a near-term solution for Mitchell's Cove is the best approach for Santa Cruz and the community. Click below to
I'm gonna
provide
go
your
through it
answer.
fast. You can do it for yourself
Thank you.
later.
Now let's take a look at Maine. There's Maine Beach, and behind it, the Santa Cruz Beach Boardwalk. You can also see the San Lorenzo River and the Beach Flats neighborhood behind the amusement park. Drag the circle to the right and see what would happen to these areas under 2.4 feet of sea level rise combined with an extreme storm. Beach Street, which runs in front of the Santa Cruz Beach Boardwalk, could be completely flooded, and the ocean may make its way close to downtown. Can you imagine wading through the streets with water up to your knees? Have you ever been in a blimp or a dirigible before? Click the target on your lower left. Welcome to the virtual planet blimp. You're floating high above Maine Beach. Now take a moment to look around and get your bearings. Use the slider to see the 2019 king tides and what the projected flooding could look like. So what can be done at Maine Beach? When you're ready, click on solutions. City of Santa Cruz is looking into short to medium and long-term adaptation solutions to manage climate risks and sea level along our coastline. Click on short-term to visualize one of these. One possible short-term adaptation option to slow erosion and buffer Maine Beach against coastal storm flooding would be to construct a living shoreline. Living shorelines use native vegetation to stabilize the shoreline, reduce erosion, and enhance coastal resources as shown here. Now click on mid to long term. One potential medium to long term solution would be to raise the concrete seawall that separates the beach from the boardwalk and Beach Street to protect infrastructure against future flood damage. Because the beach would not be able to erode back with the shoreline as sea level rises due to the seawall. However, this option may result in a narrowing of the beach and eventually Maine Beach would be lost. When you're ready, click the home button to return to the beach house. To what degree do you agree with the following statement regarding coastal management for Maine Beach? Adding more sand and fish. Rate how your awareness of sea level rise has changed as a result of this experience. Thank you for using Virtual Planet Sea Level Rise Explorer, Santa Cruz.
So what do you think about that?
Bad as I don't know. Bad. I mean, it didn't seem like, whole place is gonna be even hotter, but it's not good.
No,
It's much worse than I mean, I've seen projections for like around the Mississippi Valley and Florida, like if we could.
oh, yeah. No, we're not in bad shape compared to a lot of places in the world.
Yeah.
Florida, New York, Mumbai, Calcutta, London. Just there are an awful lot of places that started out as a port and had flat land, and a whole dense city grew up right there. And so you're right. City government may be along Oakdale Avenue someday, because once you get above the river valley, you're reasonably high, but the more we can do to reduce it, the better. Now, let me see, where was I? Here we go.
So I'd like to point out there's a lot of uncertainty in this graph. He's projecting it kind of linearly, whereas the predictions are there could be sudden changes.
Oh,
if the
absolutely.
Antarctic ice shelf breaks off.
Well,
or-
definitely.
Yeah.
And I mean, Gary
Well, you
Briggs,
don't know, right? It's uncertain.
that's it.
You can't predict it.
Gary Briggs has a book from quite a few years back that's called Then and Now or something.
Mm.
And he and somebody went around and they found pictures that were 50 or 100 years old. And then they took another picture from the same spot.
Yeah.
And so there were a bunch of arches along Westcliff that don't exist anymore, for example.
Sure.
Big rocks and all kinds of things. And from what I gathered reading it, it wasn't like it sort of eroded little bit, a little bit, a little bit. It was like a couple of storms, whap, gone. And in fact, that Mitchell's Cove, which they feature, when I first moved here in 2001, there was this thing about 30 foot tall that was kind of shaped like a head.
Yeah.
And it disappeared really quickly. I never saw it significantly damaged. It's like 1 week, where did it go? So that seemed, you're absolutely right. Things
Yeah.
happen suddenly, and we don't know exactly where, because we can't possibly know the variation in the storms or the weak spots. It's very hard to know all that, but do what we can. So this is a quick review of climate science. For something like over 5 million years, I think a lot longer than that, hundreds of millions of years, Earth has had some gases which trap a little bit of heat. And if we hadn't had that, the Earth would have been so cold that life as we know it would not have evolved. It would have been basically freezing temperature of water all the time, and that wouldn't have been great. So we had this nice blanket, but our industry, driving, etc., putting carbon dioxide, CO2, and methane, CH4, into the air, have basically thickened this blanket, and that traps heat. The same amount of energy, more or less, is still coming in as always was. Now, I like this little graphic. It's the Earth is in bed, and Grandma put too many blankets, and the poor thing is getting too hot. The kid can kick off the blankets, but the Earth can't do that easily. And where they're coming from, around here, it's mostly our driving. I'll show you more details later, but our use of cars and driving is the biggest factor. On the East Coast, it's coal-fired electricity generation, coal-fired industry, and stuff like that. Now, carbon dioxide is on this side, temperature increase is on this side, and the scientists always work in Celsius because it's the universal all over the world thing. And if Britain switched around about 1970, and they got over it real quickly. They got used to it, even though they died in the war, fuddy-duddy British people. They got totally used to it. So they use Celsius now. And but we're stuck with Fahrenheit. Now, the thing to remember, it's confusing when you learn this in high school, because not only are the temperature each degree different, they're also offset. So you have this equation you work with, and you go, oh my God. I mean, I've taught this and I still struggle sometimes. So, but the easy thing to remember is that 1 degree change Celsius is 1.8 Fahrenheit. So when they talk about Celsius and changes, when they're talking about changes only, and that's usually what they're talking about, just more or less double it. So 1.5 is 3.7 Fahrenheit. So it's significant. And well, we know it's significant. We know what's happening. But if you going back millions of years, carbon dioxide and temperature have tracked. Now, of course, there's variations. We all know the weather varies, but the overall tracking is well established. And I even saw one time a high school science fair project where the kids showed in his experiment that carbon dioxide traps heat. It's something that's been known since the mid-1800s and has never been disputed by None of the deniers ever dispute that particular fact. I found this recently, I thought this might be helpful. Because this talks about El Nino years. So the red dots are El Nino years. And they're kind of the red squares. They're sort of on the high end. La Nina years are quite a bit lower. It's not, it's totally significant, consistent, but it's a definite trend. So this very bad high here might not be quite as bad as it seems, because if we have a La Nina year, it may come down, but it's still all going in the wrong direction. But people talk a lot about this La Nina, El Nino, without ever sort of showing exactly what it does. And I thought this graph was helpful. So one of the things that isn't intuitively obvious at first glance is that when the temperature gets warmer, the rain gets heavier. And the reason is, if you think about it, on a cold day, if there's a puddle left over from the day before, it might not disappear all day. On a warm day, you spill some water, it's gone in no time, because water evaporates, is absorbed by warm air so much faster. In fact, this is the only place that you'll see F, because I just happened to find this graph. 1 degree F increase is 4% more water vapor. So 1.5 C is going to be 12% more water vapor. We already have 1.5. So 12% more moisture. And, you know, they teach you in elementary school. Evaporation, condensation, precipitation. Well, if 12% more is going up, 12% comes down. But it's not even. It's not like every storm is this much more. It's like the whole system has now more energy, more moisture. And so that little town I showed you that got wiped out, that was heavier rain than they ever seen in the past. And that's the kind of thing that's happening. What is also part of this, and I wish this would slide, this doesn't slide, it's also going more towards rain than snow. And that's important because for us in California, the snow in the Sierras has stayed up there nice and cold, and then quietly melted during spring and early summer, put water for all the cities and swimming pools and other things that are kind of wasteful. But anyway, it's been a very valuable water storage that we used to. In Asia, the Himalayas have provided water storage in a much more less formal way for billions of people in China, India, other places. And the glaciers in the Himalayas are melting. They're not getting as much snow as they used to. And that's a big long-term problem. Now, this is just quickly taking a look. This is carbon dioxide measured at Mauna Loa Observatory. In 1960, this gentleman, Charles Keeling, set this up. So this is sometimes referred to as the Keeling curve. And you can see it's been going up, going up, going up, going up, going up more steeply. Is it leveling out? Heck no, it's got to level and go down drastically, and that's going to be difficult. This is the most recent I could get a couple of days ago. So this is of December 20th. Now, does anybody know why it's jagged?
Everybody's by the time of year.
Why?
December, November to June, it goes up every year. June to September, it goes down. And that's because that's Northern Hemisphere summer. And in the Northern Hemisphere summer, the forests all across Russia, Canada, which are more or less continuous. There's bits of ocean, but not that much. It's like probably more than 80% of the land is forest. And if you look at the other side of the world, sometimes I bring that over, sometimes I forget. If you look at the other side of the world, the southern hemisphere, there's almost nothing. A few little pinpricks of islands, and that's it. Now, photosynthesis, which pulls carbon dioxide from the air, does also happen in the ocean down about that deep. In a forest, it's happening at all the levels. So that's why we get this beautiful drawdown every summer, but every winter we go back up further. Now, this shows very clearly the value of trees. And of course, some people have said, all we have to do is plant 1 trillion trees, but there's not enough land. That's been looked at and worked out, and planting trees is good. Preserving trees is good, but it's not going to solve everything. This shows how, compared to the last 10,000 years, how steeply the carbon dioxide has been going up. And this is over almost 1 million years. And we know what this is: ice age, warm, etc. Natural cycles, which are totally known and are because the sun, the earth orbit around the sun and its own rotation are not totally the same all the time. They vary. I call these wibbles and wobbles. It's just little variations, but it makes a variation in the amount of sun. And if the amount of sun coming in varies, then the temperature and the carbon dioxide vary. So, and going back, this is not part of normal natural cycles. 15 years ago, the deniers were saying, oh, there's no climate change, it's just natural cycles. Rubbish. These are natural cycles. This is a natural cycle. This is the edge of the graph. This is how steep the current changes are compared to anything that's happened any time in the past. So,
But there was a time on Earth when the CO2 was much higher, wasn't there? It was like, but we were talking hundreds of millions. I don't remember.
Yeah.
I think it's 5 million years ago is one of them. And it's a lot, it's further
Yeah,
back than
yeah.
that. And yes, carbon dioxide has been higher and life survived. In fact, there were tropical animals in Greenland. There was no ice anywhere. The ocean was 200 feet high. How this civilization with 8 billion people is going to survive? No. We don't want to go through that. That's just unthinkable. That rapid transition. So yes, life can survive. Sure.
Well, no, I'm just wondering when that was. I was trying to remember, but I believe it was more than hundreds of millions.
I've got graphs about that. Okay. So tipping points. We could spend college semester on tipping points. We're not going to do that. I picked 3 that I had recent news on. So 3 I picked were coral bleaching, hammock, which I will explain, and Arctic tundra. Anybody here have any special concerns they'd like to learn about in future classes?
The arc storms, possibility of an atmospheric river, mega storm.
So, coral reefs. Has anybody been to the Great Barrier Reef?
Yes. In the 70s,
What was it like?
it was beautiful.
And then in the 2000s, it
And
was.
in the 2000s, you had to go miles out even to see in color.
Well, it's worse now.
Oh, yeah, well, I'm sure.
And this is so sad. And the coral reef, the little coral creatures that form the basis, they have little visitors, and that's what makes them pretty colors. They're sort of related to algae. And that's what gives them color, but it also provides food for the coral. And when the water gets too warm, they go bye-bye. Now, if it's only warm for like a day or two, a week or two, I'm not quite sure of the timing, but a short time period, then the zooanthellae, as they're called, will come back and the coral can recover. But since they were also providing food for the coral, if it goes on for months, years, that's it. The coral dies permanently. And it's a problem that scientists are doing research trying to find heat-resistant corals and so forth, but this isn't stopping anytime soon, and it's sad. It's not just sad for potential visitors who could enjoy the beauty. It's sad because Nemo and a bunch of other little creatures live in the coral, and that whole food web ultimately provides food for billions of the world's population. And so loss of the coral is not just a aesthetic, scenic loss. It's a real loss of food for a lot of people.
Loss of coral also affects the land mass.
Yes. It's a big deal. Now, this is what's called AMOC. AMOC stands for Atlantic. This is the Atlantic Ocean right here. Atlantic, meridional means like a line down the middle. Overturning circulation, AMOC. So this part you might have heard about, that the Gulf Stream goes through the Gulf of Mexico and then sort of relatively close to the East Coast and then jogs over to Northern Europe. And you look at the latitude of Britain compared to really frigid places in North America. We certainly always appreciated that. And so did Norway, Sweden, Northern Germany. All these areas are quite drastically changed by this. Now, what's been typically happening is it's going along here. It's really warm here, and it's still warm, and it's evaporating. And as it evaporates, it gets cooler, but it also gets saltier. So as it gets cooler and saltier, it becomes denser and sinks. And so typically it's been sinking around here and around here. And then it goes down. So the blue is a cold, low circulation. So all the way back down the Atlantic and then around Antarctica, which of course on this kind of projection, it looks like we're really on a globe. Antarctica is a very big island, but it's an island. It's not quite like that. But when you do this kind of projection, it looks a little strange. But then eventually, like in the Indian Ocean, that cold water rises up, gets warm again, etc., and flows back around. So if this changes, it's a big deal. Now, they made one of these fantastic movies. What's called? The Day After. I've forgotten what it was called now, where this changes all of a sudden, and this young man, and his father's a researcher, and this young man and his dad says, "Oh, get out of there, it's happening." And it's like, in about one day, like, not very likely.
Yeah.
We don't know how suddenly things can happen, but we seriously doubt they happen on that kind of time scale. But what seems to be happening now, a bunch of researchers have reported that this is slowing down. This current is slowing down. And it's slowing down enough that they think it might stop. And they have evidence of it having stopped a couple of times, around about 15,000 years ago. So not too far back and impossible to understand time. So this has happened before, and it's drastic changes when it does happen.
And what's causing the slowdown?
That's a good question. I'll look and see whether this next page has it or not.
Could it be the temperature has lower density as it's heavier and cold?
There's two things, it's coming back to me. One of the things is, one very, very big factor is that the glaciers in Greenland are melting. And they're dumping cold, fresh water, huge amount of cold, fresh water into the North Atlantic. And so that affects these turning points. So that's one of the things, that cold, fresh water from Greenland. So I'm not going to read this. This is explaining about it. It could be catastrophic. And this is a video you can watch. It's a PBS video. It's quite good. It would also, it wouldn't just affect Northern Europe. It would affect, especially the east coast of the Atlantic, and to an extent, the whole world.
Ironically, it would lead to colder temperatures for northwestern Europe,
Right.
and Atlantic coast in the United States. So
Yeah. This is another problem. For a long time, the Arctic areas have had this layer called permafrost. So if you dig down a little bit, you got to a layer that was frozen all year. Even in summer, it would never thaw out. Now, what was trapped in there was the remains of plants from hundreds of thousands of years ago, and sort of decomposing ever so slowly. And when plants decompose, they produce methane. Now, I'm going to talk a lot more about methane another time, but for now, methane is a worse, 80 times worse greenhouse gas than carbon dioxide. It's really bad. It's basically what natural gas is. So this melting, when this melts, this is bad news. And this has been happening. So this is, I already talked about this. So hope everybody, did anybody not find a partner for next week? Do you have a laptop?
Yeah.
That's all right. So everybody that has one can bring them, and we'll rearrange a little bit next week as we need to. And I can bring 2 extra machines, not great ones, but they'll work. Right. So now I'm going to talk briefly about the IPCC. Has everybody heard of this? It's the International Panel on Climate Change and intergovernmental. So this is the UN body that's been putting out reports, and their reports are assessment report, AR. So AR1 appeared in the 1990s. Now, I've read portions on most of them in between, but they're awfully long. I certainly haven't read them all. Now, I'm actually going to skip briefly. This, which my friend Susan and I called the pivot graph, I'm going to look at this version instead. This is basically the same thing simplified. The previous one was from that official IPCC. This is from some other source. So this is carbon dioxide emissions. Now, early 2000s, they were going up very steeply, and it looked like we were going to go to an absolute catastrophe pretty soon. They have leveled somewhat, but it's not good enough. They have to drop. And the scientists have worked it out, and in order for to achieve no more than 1.5 or nearly 3 degrees Fahrenheit increase, they have to drop like a rock. Pretty steep to even limit to 1.7, and quite steeply. Now, we're pretty much given up on this because we're already at 1.5, and even if next year is a La Nina year and we drop below a little bit, we're worse than the Titanic. I bet everybody in here saw the movie Titanic, right? Well, they saw that ice, but why did they hit it anyway?
believe they were invulnerable, that they had that double lining of,
Yeah, but that's not that's why they went further north than they should have.
Momentum. Sure,
yeah.
They couldn't change the ship that quickly.
yeah.
They could try to turn, but it was a big, heavy ship, and you can't turn it on a dime. And the whole world is a lot bigger than the Titanic, and it's virtually impossible to change it quickly. So we have a real challenge here.
Can I challenge that just a little bit? I feel like what's missing is that, you know, like when Pearl Harbor happened, overnight, there was an emergency created and whole industries were stopped from doing what they were doing and people just turned on a dime and did all kinds of different things. We have not created that sense of emergency that would allow that precipitate drop.
You are absolutely right. And back in 2015, one of the first events I organized was trying to recruit people for a group called Climate Mobilization. And they were trying to suggest exactly that. That was all their literature. We need a, just like World War II effort, you know, Rosie and all this stuff. But it didn't catch on. It didn't even catch on very well with liberals, and the rest ignored it completely. And you're right, it could be done. So it's not impossible. And in fact, China is changing very, very rapidly. Thank you, China, because they're a big economy and it's very important. So Europe is changing a lot faster than we are. What's going to happen with Trump is, we'll see.
Go in the wrong direction.
Strong danger of going in the wrong direction. So we're in a lot of trouble. Now I'll go back to this graph because this is the official one, because this has got all kinds of good details on it. And this is from the IPCC. And at the 2015 conference, 118 nations all agreed they would cut their emissions. And this is what they agreed to, which mostly they aren't doing. And it still wouldn't have been enough because it was, they really wanted to get down to here. But so while they talked and shook hands, they were never really making a good enough commitment. And by not following through, it was even worse. Now this down here, why does it go below zero? Because it's theoretically possible to get carbon dioxide out of the air. Well, the trees are doing it all the time, but given that we haven't got enough trees, are there other ways? Now that's a whole subject of another day, but briefly, a lot of money is being put into it. Some of it is phony greenwashing. Some of it is just too expensive right now, but technologies have to start expensive and then maybe with time they become workable. We don't know, but yeah. So let's move on. So we are in trouble.
Isn't there also a risk if these technological fixes to remove greenhouse gases from the atmosphere are unleashed, that they cannot be controlled and they could take out too much and it could lead to an ice age?
What technology is that?
I don't think so. It's too hard. That the amount of carbon dioxide in the air, it's so low, you have to do a heck of a lot of pumping to even start to capture it.
Yeah.
And it's terribly expensive right now. So I think, well, that's an interesting thought. I don't believe that's practical, but I'll keep listening. Okay, so these are some of the things. So again, IPCC. So this is all the things they're saying. Increase in hot extremes, ocean acidification, sea level rise, glacier retreat, heavy precipitation, heavy rain and snow, increase in flooding, fire weather, drought. Not good. Now, I wanted to mention this, if you're not familiar with IPCC. In the IPCC vocabulary, mitigation means specifically cutting out the gases that are causing the problem. It means that very specifically. And adaptation means reducing potential harm. So seawalls are adaptation. They're not changing the problem. Walking or driving an electrical vehicle, that's cutting out emissions. So that's mitigation. It can get confusing because sometimes people will mix the words up. So when people talk about mitigating the effects of, say, sea level rise, that's not really mitigation. It's not reducing emissions. So sometimes these terms get confused. And what's important is that we have to focus on this is the biggie. We're going to do this as we absolutely need to, but this is what we absolutely have to do. So this is a bunch of stuff from them. Rapidly closing window of opportunity, deep, rapid, sustained mitigation. And financing would need to increase manyfold. Now, the recent climate COP meeting, the poorer countries were asking for 1.4 billion. And I think we agreed to 300 million or something like that, a fraction of what they had asked for. Now, honest to God, giving India solar technology and wind and batteries and all this stuff would save us money in the long run. It really would. Doesn't matter whether you care about little Indian children, you know, just from a really financial, selfish viewpoint, it would be good, but nobody seems to be thinking that kind of way.
Are you aware that India is one of the largest producers of solar panels?
They also use a lot of coal.
No,
So-
but I mean, they are the ones producing it, so we would buy it from them and give it.
So maybe that's not the technology they need, but maybe they need something so they can shut down the coal plant. So maybe they need more batteries. What I'm saying might be a few years out of date now, but somehow they need technology so they can switch away from the coal, so they can shut down the coal plants, because there's a lot of them operating. And that's part of the reason why they have such terrible air pollution, really deadly. So giving them technology would actually be a heck of a good investment, or whatever makes sense. So this is something I want to mention. Many options are available for reducing the emissions, but we need to use less energy, less flying, less driving, less buying things we don't need, less eating meat, less wasting food. And if we could do that, and it's very unpopular, a lot of people don't mention it because, oh, people don't want to change their lifestyle. You know, they're going to be forced to change their lifestyles in horrible ways. It doesn't make sense to not talk about it when that's very clear. Anyway, this is extreme weather events. And if I click on this, so you can see here, we want the worst. Yeah, it's sort of shared across the world. You can kind of see that. North America, Europe, China, and Asia. And if I click on this link, and this is one of the links that I'll be giving you, and we have to go down. See, my stupid computer almost does something. So now I can click on a particular place. So choose a country.
South Africa.
So. So now it's telling me about all the extreme things that happened in South Africa that were attributed to climate change. And they take time studying these, so they don't have a bunch of really super recent ones. But yeah, everywhere in the world it's got bad effects. So Back.
What is the size of the circle indicate on this graph?
Just the number.
Quantity of population?
No, the number of
Oh, the number
events,
itself.
the number of events they've
Oh,
documented.
okay.
Yeah. But I'll give you this link so you can explore it. Yeah, okay. So I put in some recent good news. So Santa Cruz now has renovation electrification ordinance. They tried a couple of years ago to ban natural gas because natural gas is methane, warms the atmosphere horribly, and it's bad from everywhere. It's bad from the oil wells where it's extracted, all the piping and processing it goes through before it gets to you, and then when you use it, it becomes carbon dioxide. So it's like pretty horrible.
Is that what we have in our water heaters and?
Yeah.
Gas stoves?
Well, but yes, basically most homes have, typical homes have gas furnaces, gas water heaters, gas stoves. And that's all, that's natural gas, that's methane,
Gas dryers.
gas dryers. So I've been changing one thing at a time. So I don't have, one of my neighbors went fully electric. Well, I think he just made a killing in Silicon Valley. But most of us aren't in a position to do that. But I've been keeping it in mind and changing one thing at a time. So if something breaks, we have to replace it with electric. And even though that takes a little longer, that's what we're going to do. So that's been the way I've been looking at it. But this particular thing, they tried banning new electric. Let me just finish this and I'll get back to you.
I mean, sir, a lot of these things seem to rotate through, like, there for a while, nuclear was gonna solve all of our problems. And they've gone these beautiful concrete balls on the landscape, and that's fun. And now they're going back and trying to figure out, maybe we just have to dust these reactors off and line up, well, 6 or 7 of them in a line in a row.
We had a 2-hour program on that last night.
Sorry?
We had a program on that last night, 2 hours, and a couple of experts as well as a video. But I can't really go into it in a couple of minutes. It's kind of complicated.
This is nothing to do with that.
No, this is not.
Electrification.
So the idea was, first of all, they were just going to ban new electric hookups, but Berkeley had tried it. So if you didn't have a gas line, you couldn't put one in. So a new house could not have a gas. If you didn't have, I may have said that wrong. If you didn't have gas already, you couldn't put a new gas line. Now, Berkeley had tried this, and a bunch of people go, oh, we have to cook with gas. You can't stop us cooking with gas, whatever. So our city's climate manager, Tiffany Wise West, came up with this, which I think it's good. We're supporting it because what it does means that if you have a sizable renovation, and that could be a room or two or whatever, it's not something tiny like just replacing a window. It's something that you have to have a permit for. Then one of the things you have to do is you have to pre-wire. You probably can't see all this in detail, but you have to pre-wire so that you'll be ready for electric, because that's one of the problems about changing to electric. A lot of times the electric appliances need 220 volts and your standard plug is 110. And you've got to find the electrician and get that installed before you can do it. So by pre-wiring, that's a good thing. But what they're mostly doing is they say, you can have gas if you earn 9 points. So the way you can earn 9 points is heat pump space heater. At my house, I love put them in last year. Insulation, special windows. All you have to do is add up to 9 points, and then if you want to have gas, you can. So that it's a choice, but they're forcing people to have a bunch of things happening that will make them waste less energy, waste less heat, be putting less out into the atmosphere. So that's what this is all about. And because it includes freedom of choice, we're so stuck on that sort of thing. They can get it through without getting sued. So I think that's a good move. It's a move in the right direction. And, you know, everything you can do is worthwhile.
In that vein, I'd also like to point out there's recent research showing that natural gas cooking releases a lot of toxic gases into your home.
Yes,
And it's actually harmful to your health to use natural gas for cooking.
I'm still on natural gas because I have a little place and I have a 24-inch stove.
Yeah.
And when I looked at it a few years ago, I couldn't find an electric one.
Right.
Right now I don't have the
Well,
money.
there's induction cooktops.
I know,
Induction
just
is
tops, but I wanted
Yeah,
a
I know.
stove. Anyway, but yes, you're right. So this is good. Now this is adaptation. Adaptation is not solving the problem, but it is necessary. This is a whole series of grants that a bunch of people in the county got together. So it includes Watsonville Wetlands Watch, includes City of Santa Cruz, Regeneración Pajaro Valley, and a bunch of other people. I wish I could remember them all. I've seen the slideshow twice and I loved it. When I asked the guy if I could use it, he said, oh, we're still trying to make sure the grant comes through with a new administration, so please don't show it. Okay, fine. John Hunt, UCSC, I think. Anyway, one of the things I liked about this, even though it wasn't actually cutting emissions, one thing was making a lot of people aware of the problems, but had excellent youth training, youth involved in doing the work and getting trained through Cabrillo College. So they had the whole setup. So I really liked that part of it. Another good news, Montana, the Supreme Court agreed that the state's energy policies violated Montana's constitutional right to a clean environment. And this case was brought by a bunch of young people. So there's been a case trying to go federally for at least 15 years now, I think. And the kids that started it now, well, in their 20s and 30s.
That was an Oregon.
But, and the federal government's managed to put it off. They do these legal finagling things and just put it off. But gradually, a lot of places are starting to do this kind of thing. And once it gets, it's about to get going. If it gets going, that'll be acceleration in a good direction. So, okay. So, I have flyers you can take home at the back, on the back table. I'd like to get some inputs. I'll put this back in a second. These are topics we could cover in weeks 3 and 4. Methane dioxide, tipping points, carbon removal, etc. And I've got nuclear down there, but it happens to be at the bottom. But if you would like to jot down on a little, I've got some little scraps of paper and some pens there. Anything in particular you would like me to cover, let me know. And because I've got a lot of resources on a lot of topics. And I should have a handout that says this. I don't, but I will next week. So this is where you can find slides and links from this week. The slides won't be up right away, but soon they will be. And there's a page with links already. Let me see if I can get there. So this is the Trump and green energy. This is the Santa Cruz virtual planet. There's an AMOC and roads. Yeah, so most of the links from today are there. And yeah, so you can also email me. That's my email. So, and my email is on several of the handouts at the back there. So if you want to just pick up a handout, I'll circle this for you and you can email me. And I can send you this link or any others. So, any questions before we? Oops.
Well, you mentioned sort of political activity to promote more awareness and do something about climate change. You started talking about that, and I hope we'll hear more about what's possible, what seems to be effective, how we can approach this. Because I just get the impression that, you know, telling people not to eat is not going to work. So, you know, I'm trying to figure out what is more, and I like the idea of talking about the economics of renewable, you know, more about that, how to come with that. So, more positive, not so much, you can't do this, you can't do that.
Right, well,
You
see,
know,
the whole En-ROADS thing is all about solutions. So there's 18 solutions that you get to play with, and you get to see which work well and which hardly work at all, and that you need a combination of a lot of them. So working with that is gives you a lot of insight into the issue. So that'll be next week, and we can do bunches more on solutions. So, but jot down your thoughts on a scrap of paper for me. And thank you. Oh, thank you.